Hey, folks.
Oh, good afternoon.
Hi.
Hello. Oh,
Hello.
here to go. Sorry, quick question. While I'm reviewing changes on Zonko, Fabiano, I think I saw you had a PR recently to change the create runtimes class config to be true on Kata deploy. Is that right?
Yeah,
And that only went in this last release time frame, is that right?
I think so.
Cool. Thanks.
Why?
I'm just reviewing Sonko's Helm chart docs, and I I made the mistake of just running the Helm chart as default, and then went, oh, the runtime class wasn't created, and so I just think we need to make sure we put the default in the reference, say, oh, this is only true from the next release onwards, so people
Yeah,
like me don't make mistakes.
yeah, that makes sense. And by the way, while we are reviewing things, can I just remove the OFTC IRC channel from our Etherpad?
That would be fine for me. I do not use it, and I don't think I've ever used it. But
Yeah, it's been like around 4 years that pretty much folks stopped using this.
Yeah, I think Slack doesn't support the bridge anymore either.
Yeah, so I would say just remove this. I just remove this just for the sake of avoiding folks trying to like ending up in the wrong place.
yeah, I suspect it might be elsewhere on the website and stuff. But yeah, it might be good to clean it up.
I can remove it from the website. Should be easy.
Great, thank you. Cool. Right, sorry, I
And
should.
Ildiko, if you need some review or something like that, just paste in the on the Slack and we just can approve this right away.
Will do. Thanks.
Thank you.
Okay, cool. I guess we've got quorum, although I think one of the maybe not quite the AC members who are here. Oh, Aurelian's here. We've got a legitimate AC member, not one who is status is in pending.
Hey guys, how you doing?
Hey, how's it going? So I guess we can get going. Yeah, it's been a while since we've had a normal
Steve,
meeting.
just like you are sharing your screen, you are sharing this old fire history. Do you want to share that?
I'm sharing what's oh no, I don't. Sorry, I'm sharing the wrong screen. You can see I've been testing Kata deploy stuff. Sorry. Um, Now I've got to work out how to unshare.
Don't share your bare naked photos on the other screen.
Luckily, I don't have any of those. But is this the right? Are you showing the agenda then?
Looking
Yes,
good.
this one is sharing the agenda.
Great. Thank you for pointing that out. I luckily it wasn't embarrassing. So well, it's just embarrassing that have to keep a list of all the scripts because my memory's not good. But I've had worse accidental shares in the past. We'll say that. Right. Let's crack on. So yeah, I guess we review some previous items. Yeah, it's been a while since we've had a normal AC meeting. It looks like we've got the Sonko created the issue for the starting to use GitHub for vulnerability tracking. So that one is closed out. Obviously, we want to get some progress on that. Yeah, we talked about the updating the job process to use required tests.yaml. That got merged a while ago as well. Yeah, 2 weeks ago. So that is completed. In topics, in this demotion of the Cocoa non-TE tests to make them non-required. That got merged a couple of days ago as well, I believe. So I've marked that as done.
Yep. Viner is working on fixing the KBS issue.
Yeah, that's right. So yeah, just for people's awareness, there's a problem with AKS and installing the KBS. So that means that the Cocoa tests, which run on AKS, which is just the non-TE ones, are failing. So yeah, that's why we've made that non-required.
Yeah, and so he fixed the installation part, but
Mhm.
now we're seeing some new failures, and I think that maybe the new way that we're installing the ingress part, maybe that's causing some additional control plane pods to be created in the container, right? Because now those tests are failing with an error related to CPU capacity.
Yeah. We saw the same thing in the Cocoa CI call yesterday. So yeah. I think I saw your comment where you went, let's just slow down and try and look at it before we merge it, which I think was definitely the right thing to do. So thank you.
Mhm.
Cool. So I'll say
By the way, guys, I'm not able to attend that CI meeting anymore because, with the time change, I have
Yeah.
have two conflicts actually at the same time. I don't know if anyone else is in the same boat.
Yeah, I'm not sure. Yeah, it might be worth reaching out to Viner. We can see if we can reschedule it potentially.
Mhm.
Okay. Cool. So I think the next topic is a CDI presentation by Sonko. So I guess I can stop sharing and hand the screen over.
Yeah, let me just.
Swonko, I cannot hear you.
I'm not speaking.
That
Just a
makes
second.
sense then.
Yeah. Let me just check this. Oh my goodness. Every freaking tool has a different interface for sharing, and I'm always completely lost. Use system desktop. No. Window capture. Oh my goodness. Why is this not working? Okay, I'm having trouble sharing. I'm not getting any pop-up. to choose which window or. Yeah, Steve, may I bug you to share the slides?
Yeah, sure. I can try.
There you go.
Wait a second. Okay, that's slideshow. Can you see them and in full screen?
I can see it at least.
Yep.
Yep.
Okay, great. Next slide. Okay, let me just go over one of the fundamental issues or complexity that we have with Kata related to how the kubelet communicates with the runtime and how the CRI works, and why we have hot plugging enabled in Kata per default. So essentially, the kubelet runs several phases on how to create a container. One of the phases is run sandbox. After run sandbox, it runs run create container, start container, and this is all happening in sequence. So if a pod comes in, you're creating a pod with kubectl apply. The CRI will send out several API calls to the runtime, starting with create sandbox. This is the time when we are creating the VM. And then the next call would be create container, which is the sandbox container, which is the pause container, usually in a pod to keep open the namespaces. And after the sandbox container, we are creating the workload containers. So what happens is through the runtime config, the CRI API, runtime call is run pod sandbox, gets into container D. Container D creates from this runtime config a OCI spec. OCI spec is sent to the Kata runtime, and the Kata runtime, dissects the OCI specs, creates and starts the VM. So we have at the beginning, we have a OCI spec and the VM configuration coming from the configuration toml, where we need to specify, in the case of the GPUs, for example, we need to specify, for example, the PCI root ports. How many ports do we want up front? Because we don't know how many devices are coming in, because this information of allocated devices is coming per container basis. And at the pod sandbox creation time, we don't have this information. So we need to configure the VM upfront with the base memory, with the base default vCPUs. This is usually the pod sandbox overhead, which is used to run the VM. And then for the GPU, for example, we need to specify how many PCI root ports we want to have. So let's say we configure 2 PCI root ports, the VM starts up, and the CRI then creates the pause container, which is usually just a pause thing that helps open the namespaces. Next slide. Okay, the problem we have, we don't know how many containers per pod are coming in. We don't know the resources per container, all the allocation of extended resources, all the memory, all the CPU requests, and then also as well the CDI devices per container. All this information is missing during the run pod sandbox creation time. There are folks doing some existing work on providing pass-through annotations with container D, like the CPU period, CPU quota, CPU share, and sandbox memory. That's available at the kubelet at the kubelet, and this is passed through via containerd, and that's what we're using in Kata for the static allocations of resources. There's a setting in the configuration tunnel for static allocation. So we can already have some sizing, proper sizing, but we are still missing all the information about the extended resources or CDI devices that are needed to create the VM. Next slide, please. So after the post container is created, we get a new container coming in. And this is all sequential, and it's not deterministic in which order the containers, let's say you have a pod created, you have a pod spec with 10 containers. It's not deterministic in which order those containers are coming in. Usually it's in the order that's specified in the spec, but the CRI makes no guarantee that the containers are communicated over the CRI in the order that are listed in the pod spec. So when we get a new create container call, let's say with 4 CPUs, 4 gigabytes of memory, and a BFIO device, the Kata runtime will hot plug, like, let's say 4 CPUs, 4 gigabyte memory, and hot plug the GPU, the first GPU on the first root port. And then it will start a container. So this is container one. Next slide, please. So we get another container, again requesting more CPU, more memory, and another GPU. And we're hot plugging like the second GPU on the second root port. Next slide. Now, what happens if a third container comes in and requests a third GPU? It breaks because at the beginning, we only were able to configure 2 PCI root ports because we don't know how many containers are coming in. There's also some hypervisor limitations on how many PCI root ports you can allocate per default during startup of the VM. In QEMU, it's like 16 PCI root ports, but then you're losing spaces on the PCI bus to allocate for other devices that you might need. For example, in ARM, you need this for devices and other things where you need to hot plug specific devices on a PCI root port. So you're just losing the ports on the PCI bus if you allocate too many PCI root ports at the beginning. So let me just see. Next slide is next slide. Right. So what we introduced some time ago is also cold plugging of devices, meaning all the devices are direct attached, but still we don't have any information about how many devices are coming into their extended resources, how many CDI devices are allocated. And for cold plug, we don't want to have any reconfiguration of the VM during runtime, right? And hot plug is anyway disabled per default in the case of confidential containers. But cold plug can help us also in the Kata use case. Next slide. And let me just also pass down, just link the cap in the chat. And what we are doing in the cap, in the kubelet, is that we want the kubelet to provide all the information that we need at the run pod sandbox time when we are creating the VM, so that we can do proper VM sizing. It's related to anything. It's related to mounts. It's related to like the MTDR stuff. It's related to the extended resources that, all the resources that you're allocating, the CDI devices that you're allocating, all the mounts, so that we have all the information at the beginning and we can properly size the VM. And not saying disable hot plug, there are some use cases for hot plug as well, but we can size the VM with direct attached devices, which also helps for direct attached networks, direct attached disks, and all other stuff, so that we have all the information available at run pod sandbox. And we are leveraging here only CDI devices, because CDI devices are already in the CRI API, but they are not passed through to the Kata runtime via containerd. We essentially said, okay, we are not going to focus on anything related to extended resources. So extended resources is the device manager API, And the problem with the extended resources is that extended resources can be named arbitrarily. So you could have a doc.com allocating one cat, and the runtime does not know what this really means because only the device manager API knows what it means and can deduce the information. This information is not available to the kubelet because the device manager API is built in a way that it's external. So external interfaces are providing the information that we need. So we said, okay, we are not going to support any extended resources and only solely concentrate on CDI devices. The nice thing about the CDI devices is that they can be read by the kubelet, they can be read by containerd, and they can be read by the Kata runtime. So we have a single source of truth for everything that we need. And what we can do is all the CDI devices that are allocated by the kubelet are transported via the CRI, and then in containerd, we can, one idea was just to use pass-through annotations in the OCI spec. The problem that we have here, if you have 10 containers, you have 10 different specs, and you cannot map 10 different containers to one OCI spec because containerd just creates one OCI spec, and you need to find a way how to pass through all those annotations, all those meta information that you have for all containers for a pod to the Kata runtime. So there's some open questions here on containerd and CRI-O how to do this properly, but we first need the cap that kubelet provides all those information at the run pod sandbox creation time. So CDI devices can be used by the CRI, containerd can use them, and then containerd pass through this CDI device to the Kata runtime reads this, and nv.com GPU1 can read the CDI spec from the host and then inject the CDI spec into the runtime. Next slide, please. All right. So as an example here, with CDI annotations, the runtime, the CRI runtime provides us the CDI device that's allocated through a plugin. Most notably, it will be DRA. I don't know if you heard about DRA, but DRA is the new mechanism in Kubernetes to allocate resources. If it's worth reading up because there are a lot of things going on in DRA, and we are also currently working on a DRA plugin for Kata and GPUs and other VFIO devices. So what happens is the CDI device named nvcom.gpu, I should update it. It shouldn't be named GPU, but rather pGPU as a pass-through device. Containerd reads the CDI annotation, creates a Linux device out of it, puts it in the OCI spec, the dev VFIO 16, and then Kata runtime can just use it as usual because it's the same path, OCI spec. Kata runtime reads the Linux device OCI spec and can direct attach the GPU at sandbox creation time. Now we don't need to provide any root pod sizing because already at the root at the pod sandbox size, we know which devices are coming in. So we already size the VM correctly, and we don't need to worry about how many root pods we are creating upfront. So for each create container, we have the right root pods available. Let's say if 10 containers are coming in, we have already created 10 root ports because we have all the information at the sandbox creation time. So we don't need to use any hot plug. We can use it right away and assign any VFIO device to the proper root pod. Next slide. Again, another container comes in with another CDI device. It's another VFIO device. Containerd creates, again, the OCI spec, and we can hot plug, or not hot plug, but we can attach the GPU to the correct root port. Next slide. Yeah, another example for the third container, the third GPU coming in. Again, containerd creates a Linux spec, a Linux device OCI spec, and we can just attach the GPU. Next slide. Yeah, that was what I mentioned before, how we are doing the pass-through annotations because we cannot map 10 containers to one single OCI spec. So this is a discussion going on upstream in the containerd and CRI-O. Still no solution on that. but we also have an issue where we cannot map specific features that are not mapped to CDI, how we are solving that. And I think one of the prime examples is attaching a disk and then how you prepare the disk format with the correct file system, where to mount it and stuff like that. CDI can also inject various hooks, so you can leverage create container and stop container and all the other hooks that are in the OCI spec can be also leveraged by CDI, but you need to write an external hook for more management, better management of that. Next slide. Let me just see demo. Okay, yeah. Next slide. This is the first part, and the next part is especially how Kata is handling the CDI devices. Are there any questions about the first part?
I guess it's clear. Like what I would like to understand is I spoke a little bit with Sasha during KubeCon, and he
Yeah.
mentioned to me that Sergey was blocking the.
Yeah.
What is the situation? Like I tried to talk to Sergey, but
Yeah.
not
So
like yeah. So
yeah.
tell me what is the situation?
Okay. Situation is that we have so we have Intel obviously on our side because Marcus is pushing this cap, and we have Sasha as the manager working on that as well. So we have Intel who is for this cap. I talked to Red Hat, I talked to Mronal, and to Peter Hunt and Ariel. So Red Hat is also pushing for this cap. I have Kevin Clues from NVIDIA, who is a maintainer in the kubelet space, especially on the working group of devices. He is also pro for this cap. And we have Sergey, who is from Google. And he is, I'm not saying, well, he is blocking it. I don't know if it's the not understanding or not providing, not understanding the complete issue that we have here, or if he needs more information. But I think we've added a ton of information. We had a live demo in SIGNote. Me and Marcus attended SIGNote for a couple of times, explaining all the issues. There were some security concerns because they said, "Oh, there's more information provided at sandbox creation time than during the runtime," which is kind of wrong because we said, "Hey guys, it's not more information. It's just when and how we are providing the information to the backend runtimes that are using this information." Like they were thinking like, oh, because in the mounts you have also the service account mounts and stuff like that. So there were some concerns from Chan, but we flattened those out. So yeah, the only blocking thing is currently Sergey from Google, and plan from myself, Marcus, Sasha, Murnal was to have it again raised in the next SIGNote meeting next week to see what the
Please
status is.
invite me for that, or at least like remind me about this because
Yeah. Yeah.
the conversation that I had with Dan and Sergey, Sergey brought it back again. The concern is about exposing more information than we should, right? So this was the main point. He was like not confident on this part.
Okay.
So maybe we can tailor a little bit more the presentation that you guys are gonna give at SIGNote, explicitly going to the direction that we can, help to have Sergey understanding and help him to also speak out about the issues like during the meeting, so we can try to reach an agreement there.
Yeah, but honestly, we have done that a couple of times.
Yeah, we do it
And
again. Like if
yeah,
we have to, we do it again.
yeah.
Uh, Go ahead.
No, we explained this like a couple of times, and I don't know why he still raises this. And as a SIGNote maintainer, he should know how the CRI works. Just blatantly said.
I see that Marcus has his
Yeah.
hand up for some time. Marcus, sorry that took so long for me to leave the mic.
No worries. I'm switching topic, or at least switching back to like the presentation, I guess. So the thing that I'm most interested in right now is how the CDI spec how this is propagated through from the runtime to the VM.
Yeah.
And what the final picture looks like. So maybe your second presentation elaborates
Exactly.
that. So then, okay, then
Yeah.
let's
Yeah.
postpone my question.
Yeah. Steve, please, next slide.
Hey, Zonko, I just had a question because this is the
Sure.
first time I'm looking into this. Just
Yeah.
to summarize, can you confirm that I'm understanding this right? So we need some per container information to get into Kata. And the way you're implementing this is on the kubelet side, you're having CRDs that contain that information, pass them through containerd or cryo, and then you have to modify containerd and cryo to support these CRDs.
No, it's not CRDs. The information is provided by the kubelet. We are the CRI API. The CRI
Mhm,
API is the API which is used from the kubelet to talk to runtimes, be it
mhm,
containerd, cryo, right? And
mhm,
this runtime has specifics that are not working with sandbox environments like Kata, because the
mhm,
information is coming in sequentially and at the wrong time.
mm.
So the kubelet creates first a sandbox, right?
Yep.
And then, so forget about Kata. If you're
Mhm,
creating a pod, what the kubelet does is create a sandbox, which is the pause container. The pause container is the one which shares or is kept open to keep the namespaces like network namespace and PID namespace or other namespaces open for the
mhm.
containers that are running in the pod open, so that containers can talk to each other, can share information and stuff like that, right? And the
Yep.
complete pod is again namespaced and C groups and whatever else, right? So you have
Yep.
namespaces that are shared per container, and then
Mhm,
you have the namespaces that are per pod. So now
mhm.
all this information, uh, it's coming in sequentially to Kata, and that's why we need to hot plug memory. We need to hot plug CPUs, because
Mm.
when the containers are coming in, we are getting part of the information about the complete VM, but we need the
Right.
all the all the information we need at the pod sandbox creation time, so that you can size the VM accordingly, right?
Yep. Yep.
And that's why also requests and limits are not, well, limits work, but
Yeah.
requests are not going to work,
Right. Right.
uh,
Right. Yeah. Yeah. Mhm,
right?
Well,
mhm.
So
limits work more or less, right? Because
yeah,
we added support to have the sum up of all the pods being passed down, but like we don't want this summary. We really have to have the information about each specific pod. Sorry, go
exactly.
ahead.
Yeah. So all this information is not available when we are creating the VM, and that's why we're hot plugging all this stuff in. And for confidential containers, we don't want the hypervisor to be reconfigured during runtime, because this just creates an
Yeah,
attack vector,
for sure, for
right?
sure. And in terms of API calls, you're getting those in which called the create container calls, or
So that if you look up the API, there are like 20 or 30 calls. It's
yeah,
it's create
yeah.
sandbox, start
Just if you know off the top
sandbox.
of your head. Mhm.
Yeah, create sandbox, start sandbox, create container, start container, and then
Yeah,
stop container,
yeah,
wait, or or stop container, and there's some, and then containerd has also some API calls like wait for exec, wait for this, wait for that. So it depends on how you're implementing. So there are several stages of the API. The
mhm,
CRI API defines how runtimes works. Containerd has the shim interface, which tells the backend runtimes how they need to work. Like the containerd shim v2 stuff, it's the API how containerd talks to the Kata runtime.
yeah,
And there are
mhm,
also, and there's a mapping between the CRI API, which is the kubelet to containerd or cryo, and then there's
mhm.
the containerd shim, which also cryo implemented to talk to Kata. It's the
Right,
API how containerd talks to the Kata runtime. And
right, right.
And the main problem is just the sequential nature of the CRI and non-deterministic nature of the CRI that is giving us headaches on the back end, because we don't know how many devices are coming in. We don't know how much memory in total we are getting, how much CPUs in total are. That's the main problem here that we want to try to solve. And the cap says, okay, since before the pod is at before pod admission time, all the resources are resolved at the kubelet before the first CRI API call is done to containerd. So we are using all this information, packing this into a new struct, container info, whatever, with all the init containers, with all the containers, saying, okay, those are all the containers that are going to come in later on in the sequence, with all the CPU memory and all the resources requests that we have, and also the CDI devices. The CDI is already in the CRI API. So this complete blob will send over to containerd. And now containerd needs to use this meta information, pack it up in some way, and send it over the containerd shim to Kata so that we can use it. Okay, we are getting 10 containers. They're allocating 190 gig of memory, 38 CPUs, and we can size the VM, and we don't need to do any hot plugging. Well, we are doing hot plugging when the container is coming in, because we need to know which device is associated with which container. So we are sizing the sandbox, creating all the memory, all the CPU, and the PCI topology for the VFIO devices, but we are not adding the VFIO devices. Well, if you're using cold plug, you can add the devices there, but if you're still using hot plug, we are hot plugging the GPU devices per container, because then you know which device belongs to which container. But anyway, you would have this with the cap, you would have this anyway. And today, what we are doing is, for the GPU at least, is create the CDI annotations in the pod spec. And CDI annotations can be passed through by containerd. And use these CDI annotations to size the VM, and then use the information by the device plugin, which provides the VFIO device during create container runtime, to hot plug the GPU to the right container. So this is currently how it's solved with the GPUs. But maybe it's going to be more clearer when I go over the next slides.
Sorry, does this also solve the requests and limits problem then?
Yeah,
Or
because requests and limits are propagated at Red Pod Sandbox, right? So what you can do is update the default memory to the size of the requests.
Yeah.
And then have the limits also set to the max memory, so that the Kata can hot plug more memory if it's needed. Because currently only limits are working to some extent. And also the issues we have, like with volume mounts and sizes of MTDers, and also subpath is not working with config maps right now, because subpath is only done in the kubelet. So the kubelet does the subpath config map mount. That's the problem right now. And with this information of all the mounts at Sandbox, we can use subpaths with config maps in Kata. So there are a ton of things that this cap going to resolve in the Kata Coco space, for all the things where we still have the limitations. If you look at the Kata limitations doc, most of them will be solved by this cap.
Nice, great. Thank you for the info.
Can I
So
also
if you look,
make sure that I understand correctly? I mean, I don't quite see the relation. I mean, like how this is gonna help supporting requests, but I'd put that aside for the moment. And my question is, do I understand it correctly that the problem is pretty much the same as with hot plugging CPUs and memory? And the only difference is that, like, if you don't know how many CPUs or how much memory you will need, you will just set max vCPUs and max memory in a configuration file to whatever number because it's essentially free. Whereas with the CDI devices, with this stuff, doing so has a cost. Is that the difference?
What do you mean at a cost?
You said that like pre-allocating, just in case, basically pre-allocating 16 root ports
Yeah,
has a cost.
exactly.
Unlike setting max memory to the whole host memory, which essentially has no cost. You can do it basically, and you don't necessarily pay for it. Whereas with the VFIO devices, doing the equivalent of setting max memory does have a cost,
Okay,
so you
got
don't
it.
want to do it.
Yeah, but also in the case of so one advice is to always set limits with Kata pods because it has a cost. Because if you have a pod that can allocate the complete memory of a node, and it's doing so, you're not going to be able to add another pod that has max memory set to the complete node's memory.
Yeah, sure.
If you're using
I was speaking about cold plugged values. Like if I don't know how much memory containers
yeah.
incoming pod will need,
Yeah.
I can just set default memory to whatever
Oh, yeah, got it.
seems reasonable, and then set max memory to a bigger number or even the all of host memory, and I pay basically nothing for that. Whereas, so is the difference? Is this the difference? Because, I mean, if this is not the difference, then I don't quite understand why this is needed. Why this is not sort of the same way as let's say memory. You start your VM with a quad gig, and then as the individual containers are incoming, if all of them properly set their limits, that amount of memory is hot plugged and you're fine. So I'm trying to make sure I understand why this algorithm that's used successfully with CPUs and memory cannot be used with VFIO devices.
Because you don't know how many GPUs are coming in. How do you know if you set your PCI root ports to 16, you're losing, you're wasting a lot of resources. Then some other things may break. If your setting is always to 8, it may work. But what if you get 9? Then you're breaking your VM. You cannot start up.
And Zvonko, let me just try to Pavel, there is like you say that what we have right now, the algorithm that we have right now is working. It's working for the case where we cannot plug. There are several cases where we cannot hot, right? There is no hot plug on Firecracker. There is no hot plug on confidential computing. So it's not actually working. It's working for some cases, and the CAP that Shared is trying to solve this for all those cases, not only, you know what I mean?
Yeah,
And
the case where you cannot hot plug is obvious. Yeah.
but even with hot plug, what are your so the default memory in Kata and the default CPUs is the pod overhead, which is just used to support the VM. It's not the workload memory per se. So if you are setting too much, so I think you need to also understand that there are use cases where people are using 500 gigs or 1 terabyte of memory per pod. And you have a machine, if you're over allocating, you're wasting a ton of resources. So default memory should really be only set, and default CPUs should only be set to the pod overhead, which is used to support the VM. And the workload coming in with the limits, and every Kata pod should set limits in a Kubernetes environment, Otherwise, you're wasting a ton of resources if a pod can allocate all of the memory of a node. You want to have proper bin packing on the host of all the pods. You don't want to waste precious resources. So saying that it works, yes, technically it works, but how do you solve the bin packing properly if every pod can allocate as much memory as on the node? You don't want to do that. Otherwise, you're getting OM killed. And Weird IOFS is backed by dev shared memory. And if you don't mount the dev shared memory on the host properly, you will get OM killed. And if you're running such things in a production saying, okay, I don't care, I'm allocating 500 gig here, 500 gig there, you're just wasting resources and you're getting things OM killed. Technically it works, but if you're running such things in production, it does not work. Because you need always to size the VM properly and size your workloads properly. You only have a finite amount of memory. You cannot just say, okay, I mean, if you have like 128 CPUs, 2 terabytes of memory, and you're running just one container that's used one CPU and 2 gigs of memory, that's you don't care. But if you're having bursts of hundreds of pods, then it's a completely different story here.
Yeah, I'm well aware of that, and I'm actually afraid that we don't necessarily do it in OpenShift, and I've been advocating for us to do this. So yeah, we're in complete agreement here. So I guess the answer to my question is we cannot just like pre-allocate root ports for the maximum possible amount of VFIO devices because we'd pay a price for that. Is that correct? As
well as for memory. You're paying a price because you cannot schedule as much pods that you may need. You cannot just, I mean, as I said before, everything has a price. Allocating memory has a price because you allocated too much memory that you don't need. How do you know that for proper bin packing? You're paying a price if you allocate too many pods, if you're allocating.
Well, with memory, you can cold plug just the amount of memory that's the overhead, as you said.
Yeah.
Maybe quarter a gig, maybe even less. And then if you also set max memory high enough, then you can hot plug anything you want, and you are not wasting anything. I think.
Folks, let me
No.
just like this is going to like a little bit orthogonal to what happens to the second part of the slides. I have to drop in 2 minutes, and I really would like to see the second part, but I think it's not gonna happen. Zvonko, are you okay on giving the second part next week?
Sure.
Marcus, you wanted to see this part as well. Is it fine if Zvonko leaves this for next week? We also have another topic for today, and I literally have to drop in 2 minutes, and I'm being selfish here, asking for that. But if everyone is okay with me being selfish,
I wouldn't mind talking, do some reading too. So +1 for me.
Yep, also works for me.
okay, Zvonko, please leave the second part of the presentation for next week.
Yep.
And please get back to the discussion then. I have to drop right now. Sorry about that. And yeah, I will catch up with you guys next week. Thanks a lot for the first part of the presentation, Zvonko. I'm looking forward to go through the next part of the presentation as well.
See you, man.
Okay, do we want to tidy up conversation we're having, or should we park that for now and look at the next topic?
So I don't know. I feel bad now for kind of hijacking this. So, but I'm still not sure what you mean when you say that even with memory hot plugging you pay a price. I honestly still don't see how. But
Because
we can
Yeah, okay. One example. You schedule a pod that has default memory of 2 gig, and you say max memory is the complete memory of the node. Okay? And the workload runs and allocates all the memory of the node. How many pods, additional pods, can you schedule on the node?
Well, I guess none, but then like
Exactly.
if a pod actually needs the whole memory of the host, then I'd say it's kind of fine, right?
Depends on the use case.
Well, my point is like you have a host with 128 gigs, and you start a pod. I mean a VM cold plugged with 128 megs of memory, so a really small memory, and then and you also set a max memory to the whole memory of the host.
Okay.
So then if it turns out that the pod actually has just a single container which eats a single gig of memory, so you basically have one 28 gigs of memory on the host.
Yeah.
You set max memory to basically this pod is able to hot plug all of the memory of the host, but then you
It
only
is.
actually use, you know, a little bit more than 1 gig.
Okay.
Then
That's the
I-
default. That's the
yeah.
default.
So
But who is who is
I
governing
don't.
who is governing how much memory is going to hot plugged?
The pod, basically the
Right. The limits.
the limits, yeah.
The
So
limits.
so
And the cap.
I'm asking a question. Do you pay a price in resources for this setup?
No.
Because I don't see any.
No, you're not paying a price.
Okay.
But we want to support requests as well. There's two-part question here. That's what he said before. Limits are kind of supported in Kata, but we want to support requests as well.
So the request support is another thing that's not actually clear to me, because supporting requests in Kata should be internal to the VM, I believe. But I don't know if we have enough time to go into this discussion.
Well, if you want to have discussion, let's create some issues and then we can discuss there.
Yeah, I'm basically just asking a question.
Sure.
It's not a discussion like I have an opinion against yours opinion. I'm just not clear how the requests interact with this cap. So we can clear this up on Slack, I believe, because I believe we still have a point on the agenda.
Yeah, I think let's jump back. But yeah, thanks for the questions and discussions. Obviously, we need needed more than 40 minutes or something, so we can carry that over next week. So I guess, Ildiko, the last topic was something you wanted to highlight.
I just wanted to check in about this. I was pointed to it not like recently. So apparently there is a maintainer month. I think the campaign is organized primarily by GitHub, and OSI, the open source initiative, is partnering with them to support the effort. And to my knowledge, I think this is like the 5th time that they're having this, and this time around the theme is security. So they are looking into both highlighting good security practices that open source projects may already follow or should, as well as like giving the opportunity to also give recognition to people within communities who are instrumental in putting these in place or carrying them out. So I wanted to check in if there's anyone in the Kata community that you all would think about nominating to try and see if we can get the spotlight in an opensource.net article, or if there is anyone who would be interested and available to attend the OSI's town hall meeting to talk about these kind of things, or interested in the other two options. Well, mainly the blog post, if you all have security practices that you would like to share, and then we can help. The Open Infra Foundation can help in terms of putting that on social media and driving some attention to it. It's an opportunity that I wanted to make sure that you all are aware of, and let me know if you would like to nominate a person, or anyone is interested in the blog post to share security practices, or any of these.
Cool. Thanks for sharing. I think probably more interested in reading other blog posts about the security practices. I know we've had a few discussions about how we can improve our stuff, but yeah, that sounds good. So yeah,
Maybe I think the town hall will probably be a good thing to attend, even just to learn. I don't think that it will be a closed meeting like that. But again, I'm still just learning about the details of the event myself. But in terms of learning, I think this is probably a good opportunity, even if the person who attends will not be able to speak up.
Yeah, I think that makes sense. I'll definitely take a look about it. It sounds like might be a good place to learn.
Yeah, I'll try to attend myself as well, and see if I can bring back some things, unless something else comes up for that day. So I'll do my best to collect some things that the community can look into.
Cool. Great. Thanks for sharing it. Sounds interesting. Any last topics? We've got a minute or two, or issues anyone wants to highlight. I guess a question, I'm not quite sure what the status of the release is. We maybe we need to take it to Slack, but
I just had one thing to bring up, unrelated to the release. I was gonna request to add Sumed from my team to the contributors team on GitHub. He's been working on Gen policy lately, and agent ETL, and then he also has various fixes, for the CI. So yeah, I just wanted to call that out, and I'll create an issue in the community repo later on, if you guys can go and take a look.
thanks. Do we have somebody who's on the list for the release to look after at this time? I guess that's the first question.
I added myself to the current release.
Okay, cool.
Yeah.
Are we blocked by any PRs, or maybe we can take this into Slack?
Yeah.
But yeah, if any help is needed with the release, then yeah, please shout and I'll try and help.
Yeah, just which PRs we want to have.
Yep.
Have in the release. So there's still some discrepancy here, but yeah, let's take it as like.
Yep, great, cool. Thanks for joining, folks, and yeah, thanks very much, Sonko, for presenting. Looking forward to the second half next week, and speak to you soon.
Yeah, thank you, folks. Thank you, Zvonko. That was
Thanks.
very
Take care.
interesting.
Thank you, guys.
Thanks. Bye.
Bye-bye.